VLPSos here. This is a video lesson for Python programming, shapes. This program is beginning with a stub file. The stub file is being used to form the basics, the essentials of a graphics program. In this case, the file cppg_stub_0 was used. And in that stub, we have the display caption being stub0. We're going to change that to shapes, the topic of this lesson. Something else that we're going to change in our stub to better accommodate what we're going to write is the screen width will be changed from 800 to 600 pixels and the screen height from 500 to 400 pixels to make it a little bit smaller so that we can see not only the graphic screen but other stuff going on. Our stub should run. Our frame loop does not provide any way of exiting, so we'll have to force it to quit, but we can confirm that we start, we get a relatively small graphics window, and we have to break out of the while loop in order to quit our program. We X idle in order to get rid of the graphics window. Rather than closing the graphics window, we close what's controlling that window. So we're going to get to the basics of drawing graphics, lines, circles, rectangles, and polygons. And to do that, we're going to need a color to draw on the black surface that we saw. So I'm going to introduce a new section of code that is pretty typical, and we'll put it into a modified stub as we move forward, a section in our code with under the comment colors where we list the colors that we use. In this case, we're going to make white shapes on a black surface. So we need to declare what the white color is. There will be a lot more about color in the next lesson. For now, we're going to set a variable equal to white, all in capitals, so that we recognize those variables as colors when they're all in capitals. And we're going to set it equal to a tuple of 3. Tuples are like lists, but they're immutable. They can't be changed or modified or added or subtracted to once we create them. So white is equal to a tuple of 3, and the values in the tuple, there are 3 of them, are 255. More about color in the next lesson and why white is 255, 255, 255. Now that we have a color, I'm going to go to the frame loop, and I'm going to make space in the frame loop, the while loop, that we use to create still images of graphics. And because it's a while loop and continues to process, it'll continue to make these still pictures, and if our still pictures change at all, in this program they won't, but if they change, it'll give the illusion of motion just like a film gives the illusion of motion by showing pictures very quickly. So in our frame loop, we'll compose a graphic image. And we'll do that by first drawing a line, and then circle, a rectangle, and a polygon. And we do that before we run the update function. The update function takes all those changes and updates the graphics from the user's perspective so the user can see the changes. And then to finish our frame, we process the event queue, which is necessary, though we're not using and dealing with input, it's necessary to be there so that the event queue, which is a place in memory, doesn't get filled up with user input and freeze or stall our program. To create a line from Pygame, the draw family of functions, we use the line function. And the argument for drawing graphics are quite sophisticated. So in the comment, in parentheses, I'm going to put the argument for a line descriptively. The first thing that we need in drawing a line is the surface where we're going to draw that line. The surface is a rectangular matrix of pixels, of color. We only have one surface in this program, and that's screen. The primary display is a surface where we can draw graphics. And we set our screen to be the primary surface with the set mode. So when we draw the line, the surface that will be drawn to will be the screen. It could be other things if we created other surfaces to draw on, but we'll get to that in future lessons. The next thing that a line needs is a color, the color of the line. After that, we need two endpoints. The line will be drawn in between two endpoints. So an endpoint is a coordinate. That means that an endpoint needs two values. Much like in algebra, an x and a y value will find a coordinate on a graph or a two-dimensional graph. But we'll need two because the line will be in between those two coordinates. And to finish up a line, we need the thickness of the line. So with this reminder as a comment, let's draw a line. The surface, the first thing in the argument, the surface it will be drawn to is the screen. The second thing in the argument is a color. It's going to be that white that we prepared. An endpoint needs to be a tuple of two, like algebraic coordinates. The first endpoint in this example will be the origin, whatever that is, at 0, 0. And the second endpoint will be 200 pixels horizontally and 200 pixels vertically from the origin. Finally, we'll end with the line thickness, and we'll get a line thickness of 3. So there we have the argument of a line, surface color, two endpoints, which are each a tuple of 2, and then the last is the line thickness in pixels. We can save this and observe a line being drawn. In our graphic screen, we have a white line. It's 3 pixels thick. Notice that the endpoints, which should be the origin and 200, 200, might be a little bit different than you expected. In algebra class, the origin in a rectangle like this is typically at the bottom left. We would call this in algebra the first quadrant. But in graphics and computer graphics, a vertical value of 200 means 200 down from the top. So we have an origin, a coordinate of 0, 0 at the upper left. The first endpoint of this line is the upper left of this surface. And then the 200, 200 is the horizontal, which is typical to algebra, to the right of 200 pixels, but the vertical coordinate of 200 is 200 down. We'll have to get used to that because it isn't going to change. I got to quit idle in order to close my graphics screen and move on to an example of drawing a circle. So we draw a circle with a call to pygame.draw.circle, which is another sophisticated function that I will put as a comment, a descriptive version of the argument. A circle needs first the surface that it's going to be drawn on, just like a line. A circle also then needs a color. The circle then needs, as the third part, a center location. So that'll be a tuple of 2, a coordinate, which will be the center of the circle. After that, we need a radius in pixels of the circle. So from the center, the radius is going to be the distance from the center to the edge. And then a line thickness. For example, let's draw a specific circle. We'll draw it to the screen. Second is the color of the circle. Then a tuple of 2 to be the center location of the circle. I'm going to choose 100, 100. That'll be 100 to the right of the origin and 100 down. And remember that the origin, the coordinate 0, 0, is the top left instead of the bottom left. The next thing we need for our circle is a radius. I'll give it 25 pixels. And the next thing is a line thickness, 5. If we save and run, we should see both a line and a circle drawn. That's what we see. The center of this circle is at 100, 100. It's 100 to the right and 100 down from the top. It has a line thickness of 5, so you can compare it to the line's line thickness of 3 and a radius of 25. I'm going to draw another circle by copying this argument, changing the coordinate of the center to 200, 200, which is the same as the endpoint of this line, and I'm going to make a line thickness of 0 to see what happens. I'm going to keep the radius the same. So we can see that we have a second circle, but it's filled in. It had a line thickness of 0, which means that the circle won't be invisible. 0 in the argument for line thickness means fill it in. So we can create what's called a disk. And we can see that that disk must be centered at the end point of the line. Onto a rectangle. I'm going to begin by giving the argument of a rectangle as a description comment. Rectangle needs first the surface that it's drawn to, the color of that rectangle, and then a fairly complicated tuple of 4. A tuple of 4 includes those 4 values. That is the x and y location of the top left corner of the rectangle. And then, once the top left corner of the rectangle is determined, from there we'll supply the width and the height. And the height, of course, is going to go down, because like a vertical coordinate, a positive value means down. So our rectangle will have, in the argument, the x and y coordinates for the top left corner of the rectangle, and then a width, which we'll call w, and then an h, which we'll call height, which will finish that tuple of 4. But not the argument, because we also need to supply, for a rectangle, the line thickness. Now let's create a specific rectangle and see it with the call to the function pygame.draw.rect. The surface will be the screen. The color will be white. Then that tuple of 4, we will give the x-coordinate 100, y-coordinate 200, the width of 40 pixels, and the height of 80 pixels, which will end that tuple of 4, and the last thing in the argument is the line thickness, in this case 10. Let's save it and run. We have a rectangle here. Notice it's a little bit odd with a line thickness of 10. It's like it drew lines 10 pixels wide, but the ends of those lines that were drawn didn't match up to make nice sharp corners of the rectangle. That's what happens when you have a line thickness other than 1. Notice that the height is taller than it is wide because we have a height of 80 pixels and a width of only 40. If we change this line thickness of 1, I'm modifying it, we can see that we have a rectangle that does have sharp corners because it's only 1 pixel that we can see there. Now we can draw any shape we wish. Polygon is generic, and the way that we draw a polygon is by declaring a list of points, which would be the vertices of the polygon, and Python will locate all of those points, draw sides or lines in between those points, and if the line thickness is 0, it will also fill it in. We have to be careful the order which we get the points so that they don't cross each other. It's very typical to declare or to define the list of points which will be used as the vertices of the polygon first, or independent of the argument of the polygon. And we're going to do that. We're going to call it vertex list. But first, the argument of a polygon descriptively. A polygon needs first the surface in which it's going to be drawn to, the color, then a list of points or vertices, and it could be any amount, and then the line thickness. And a line thickness of 0 means fill it in. So we're going to create a simple polygon. We're going to make a triangle by only supplying 3 vertices in the list. Our vertex list needs to be tuples of 2. The first coordinate for the first vertex will be at 250, and then another tuple of 2 at 360, so that's farther to the right and a little bit more down. And then the last coordinate will be in between horizontally, 200 and 300, so 250, and then lower than 60, we'll choose 80. We have the vertex list. There are 3 tuples of 2, 3 coordinates. So let's create a polygon by calling from Pygame, from draw, the function polygon, and which we will, well, in the notes, we should call this a surface. But the specific surface that we're using is screen, the color white again, and then the list of vertices, which we had previously defined, so we'll just put it into the argument here, vertex list, and then the line thickness, let's fill it in with a 0. And we had an error. Oh, I see it. Instead of a period, I put a comma. How strange. And another error. Skeen is not defined. It certainly isn't. We need an R for it to be a screen. And then we can see that we have our polygon, which is a triangle, has 3 vertices. So in this program, we've learned to draw some things. Moving on. Now you. You have seen how to make lines and a few basic shapes. Begin a new program using the stub file called cppg stub0. Make a simple program that displays a circle inscribed in a square that is centered within a graphics window. And inscribed means the circle is touching but not crossing the sides of the square.